Alright everybody, let's try out a couple examples here. So what if I have a book on a table? There we are. And the book is not changing its state of motion. That means that we can draw a free body diagram represented by a dot. The gravity of the Earth on the book is represented by W, vector, E, comma, B, and that's the weight. All right. Well, what if we assigned that weight to be 10 newtons? All right, well, that's the magnitude of the gravitational force on the book. As long as the book is not changing its state of motion, that means that there's got to be some other force acting on the book straight up in opposition to that weight in order to make sure that the forces are balanced out. And the force that's acting on the book is the force of the table pushing up on the book. So I'm going to draw an arrow that's the same length as the downward arrow, except this is a different force, different type of force. This is the normal force of the table on the book. And the magnitude of this force has to be equal to that downward force in order for the forces to balance out. And thus, there is no net force here.